This video will discuss Gaussian elimination, but in the process it will also describe the Gauss-Jordan elimination. But this video will stop only at the Gauss elimination. So let's start with what is the Gauss-Jordan elimination. It is a process in which we can solve for systems of linear equations. First thing we need to do is to place the system in an augmented matrix. Then we're going to use our 3-row operations to get augmented matrix to look like this. It looks like the identity matrix augmented with an answer column. And this structure of a matrix is known as the reduced row echelon form. That's for Gauss-Jordan. For Gauss it looks almost the same, except that the zeros on the top half of the diagonal are whatever number. It doesn't have to be 0. But we'll get more to that later. Do row operations, in particular in this order. We want to get A11. Remember that is the element in row 1, column 1 to be 1. And then we're going to get zeros underneath it. And then we're going to go to A22. We're going to make that a 1. And then we're going to get zeros below and above it. And then we're going to go to A33, make that a 1, and then make zeros above that. Then the last thing we need to do is to state our solution set as a ordered pair if we're only doing a 2-equation system, or as a triplet, an ordered triplet, if we're doing a 3-equation system. So I have example number 1 here that we can take a look at. So the first thing I'm going to do is put this into augmented form. So our augmented matrix would be 2, -1, 1, 0, and 1, 0, 1, 1, and 1, 2, 0, 8. So notice that the first thing we want to do is to get the position A11 to be a 1. So we want this to be a 1. And we have 3 choices that we can do. We can switch rows, we can multiply the row, or we can add something to that row. So what we're going to do is we're just going to switch. So I am going to switch row 1 and row 2. So I can denote it like this. We've also seen that we can say that row 1 and row 2 are switched. So we can do a double arrowed line in between them. So our next matrix would look like this, where we did not do anything to row 3. So we'll write that down. I always like to start off with stuff we didn't didn't change. And then I'm going to put 1, 0, 1, 1 at the top, and 2, -1, 1, 0 in the middle. So all I did was switch those 2 rows. So the next thing, so we've done that, so I'm going to check that off. The next thing we need to do is to get what's below it in 2, 1 and 3, 1 to be 0. So in other words, we need to get this to be a 0 and this to be a 0. So I'm going to do it kind of together, and you'll see what I'm talking about. So the first thing I'm going to do is I am going to multiply this top row by a -1, and then I'm going to add it to row number 3, because -1 plus 1 will give me that 0. So what we're doing here is we are getting -1 and multiplying row 1 by that, and then we're adding it to row 3, and we're going to put it in row 3. So that's my denotation. So I usually do it with my little arrows up here, but I wanted to make sure that in my math lab you may see it written like this, and I wanted you to make sure you knew what that means. The other one that we're going to do is I'm going to multiply that first row by a -2 and add it to this second row. So what we're going to do is we're going to get -2, multiply it times row 1, and add it to row 2 and put it into row 2. So my next matrix will look like this. So I'm going to show them to you in different colors so that you can see that. So I'm going to keep my first row because I like that 1 right where it is. And then we're going to change row number 2, which is in orange. So I'm going to show it to you in orange. So what I'm doing is I'm multiplying -2 times 1 and get -2, -2 times 0 and get 0, negative 2 times 1 and get negative 2, and negative 2 times 1 and get negative 2. Then I'm going to add these orange numbers to row number 2, and we're going to see that negative 2 plus 2 will give me a 0, which we're not surprised. That was the whole purpose of this. We're going to get this 0, and we're going to add it to this negative 1. We're going to get negative 1. We're going to get this negative 2, and we're going to add it to this 1 right here. We're going to get negative 1. And then we're going to get this negative 2, and we're going to add it to this 0, and we're going to get negative 2. So I'm going to get my red pen, and we're going to do something similar to that, except this time we're going to multiply row 1 by negative 1. So here I am, negative 1 times 1 will give me negative 1. Negative 1 times 0 is 0. Negative 1 times 1 is 1. And negative 1 times 1 is negative 1. This should be a negative. Be careful with those negatives. I can't stress that enough. So slow down. So I have negative 1 times 1. So we know that just means everybody's going to change signs. And then now we're going to add to row 3. So negative 1 plus 1 is 0, which we're not surprised. We designed it that way. 0 plus 2 is going to be 2. Negative 1 plus 0 is going to be negative 1. And negative 1 plus 8 is going to be 7. So we're almost done. We've done those two. Now we need to get a 2, 2. In other words, the element in the 2, 2 position in the second row, second column. We need this guy right here, and I'm going to highlight it in blue. We need this guy to equal to a 1. So all I'm going to do for this is multiply it times a negative 1. So in notation, we can say what we're doing is we're going to get negative 1, and we're going to multiply it times R2 and put that in R2. So this is what my next matrix will look like. Notice that I am going to keep row 1 just the way it is. We're going to keep row 3 the way it is. And then row 2 will change, and I'm just multiplying negative 1 times 0 is 0. Negative 1 times a negative 1 is a positive 1. Negative 1 times a negative 1 is a positive 1. And negative 1 times a negative 2 is a positive 2. So we've done that part. Now we need to get this one down here to be a 0. We got that one a 0. That's just sheer luck. But we need to get this one down here to be a 0. So we need to get this 2 to be a 0. So what we're going to do is we're going to multiply row 2, the one that we just found. We're going to multiply that times negative 2, and then we're going to add it to row 3. So I'm going to get negative 2, multiply it times row 2. We're going to add it to row 3 and put it into row 3. So let's do that. We're going to multiply times negative 2 to the 0, and that's how we're going to get 0. Negative 2 times the 1, I'm going to get negative 2. Negative 2 times the 1, I'm going to get negative 2. And negative 2 times the 2 and get negative 4. So now we're going to add. So here we are adding. We're going to add this to row 3 so we can see what we're going to do. So here's our next matrix. We have the first one we did not change. The second one we did not change. But the third one we are adding 0 plus 0 to get 0. We're adding negative 2 and positive 2 to get 0. We're adding negative 2 to negative 1 to get negative 3. And we're going to add negative 4 to 7 and get a positive 3. So we're almost done. We've done the part of getting 2, 3 to equal to 0. I'm going to stop right there and go to the last step section here. We want to get this guy right here to be a 1. So I am going to multiply by a negative 1/3 for row 3. So I'm going to do negative 1/3 of row 3 and place it into row 3. And to do that, we still keep our first row, our second row, And our third row will become 1/3 times this is 0. 1/3 times negative 1/3 times 0 is 0. So it's negative 1/3 times a negative 3, and that will equal to a positive 1. And a negative 1/3 times 3 is going to give me a negative 1. Here we have reached our Gauss elimination. This is also known as the REF, R-E-F, row echelon form, that can be found in your graphing calculator. And let's solve from here, and then I'll do a separate video that will talk about doing the Gauss-Jordan part. So here we go. From here, we can rewrite our statements as, I'm going to do the third row. That third row is z is equal to negative 1. This second row says 0x plus 1y plus 1z is equal to 2. And the top row says x plus z is equal to 1. So we're going to use backward substitution to solve this one. So we already know z is equal to negative 1. So we're going to have y plus z is equal to 2. We're going to change that z to the number negative 1. And then we're going to solve. We find that y is equal to 3. Then we're going to go to that first equation that says x plus z is equal to 1. We're going to change that z to negative 1, so we're going to have x plus a negative 1 is equal to 1. So we're going to add 1 to both sides, and we find x is equal to 2. And we have solved this system. The solution set would be 2, 3, negative 1. That's our ordered triplet. And that concludes this video.